Hello, this video is for IXL J1, A1.J.1 Model and solve equations using algebra tiles. This activity corresponds with lesson 2-1 of your textbook titled Solving One-Step Equations, where our objective is to solve one-step equations in one variable. In this activity, IXL is wanting us to use algebra tiles to model and solve equations. And so we might want to have a discussion about what algebra tiles are. In your textbook, there is a page that discusses algebra tiles, and this is precedes the activities in that lesson. So if you want to see this image, you can see it in your textbook. It says that algebra tiles can help you understand how to solve one-step equations in one variable. You can use the algebra tiles shown below to model equations. Notice that the yellow tile is positive and the red tile is negative. Together they form a zero pair, which represents 0. So we see here that the tan sides, and that's not a very good image of it, but that's supposed to look like that. But the tan side is a positive 1. The red side is a negative 1. And each of these bars represent the variable x. And also, they don't show it here, but we'll see some where there is a red bar and it represents a negative x as well. In the activity, they ask us to model and solve x minus 2 equals 4. So here we have x, we see our green x here, minus 2, so we have negative 2, and equals, this black line is our equal sign, and then 4 positives, and we have 4 positives here. So we have modeled the equation using the tiles. Then on the next step, it says the green tile represents the x. To get the green tile by itself on one side of the equation, we need to add 2 yellow tiles to each side. Remember that a yellow tile and a red tile form a 0 pair, and then we can remove all the 0 pairs. So note here in red, it's noticed that we have we're adding 2 positive x, and you see there and there we've added 2 positive x, so we have 1, 2, 0 pairs. But if we add 2 positives to the right or to the left, we're going to have to add them to the right as well. So we add those there. We now have 6 of them. And now that these have a value of 0, we can remove those. Little note with the little arrow there where it's showing that they're being removed. That leaves us with just 1x equals a positive 6. So the green tile equals 6 yellow tiles. This represents x equals 6. The solution of x minus 2 equals 4 is 6. So if we look at IXL A1.J.1 model and solve equations using algebra tiles, the first question asks us which set of algebra tiles represents the equation 2x plus 4 equals 16. So we should be looking for 2 x's. Well, here we have 2 and here we have 4. Looks like here there are 6 of them, and here looks like about 8 of them there. So right away we should note that the first one here is our correct answer, because we have 2 x's there. Let's also go ahead and check the plus 4. I do have 4 positives here. Then the equal sign. See the equal sign. Then on the right should be 16. Well, we can count these a little bit easier by looking at them as a grid. We have 3 down and 5 across in this grid right here. So 3 by 5 is 15. Plus 1 more is 16. So indeed, this first selection does model the equation 2x plus 4 equals 16, so the first one is our correct answer. For the next question, it says which equation does the set of algebra tiles represent? So we have negative x's. Remember, the textbook only showed green ones. I told you we'd see some red ones. So the opposite side of each of those algebra tiles, the x's are green on one side for positive and red on the other side for negative, whereas the units are tan on the positive side and red on the negative side. So red's always the negative side. So we have 2 negatives over here. So this is going to be a negative 2x equals. And then on the right, let's count this grid right here first, the solid grid that we have. We have 3 down, 4 across, that's 12, plus 2 more is going to be 14. So we'll put that 14 in there. And so we should be looking for negative 2x equals 14. And it looks like we see down here on the end that we have negative 2x equals negative 14. So our fourth selection is the correct answer. For the next question, They ask us which set of algebra tiles represents the equation 9x minus, 9x equals 9. So we're looking for 9x's. Well, we can see right away that there are too few x's here. So we can definitely rule out the last two as being the incorrect answers. And then let's go back up to the other. Looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Indeed, both of these have 9 x's in them. And now for the right side, we'll check that. We're looking for 9. Here we see that we have a 3 by 3, so there are 9 here. So indeed, we have 9 x's here equals 9 positive units here. So our first selection is the correct one. Too many units on the right side of the equation for it to be the second answer, so this one is also incorrect. For the next question, they're asking us to, what equation does this set of algebra tiles represent? So on the left we have, looks like 4, 1, 2, 3, 4 negative x's. So we'll go ahead and put our negative 4x equal sign. And then on the right, looks like we have 3, another 3 for 6, 7, 8 total. So negative 4x is equal to a positive 8. So this is the equation that is represented by these algebra tiles. For the next problem, we have used algebra tiles to solve for x plus 9 equals 11. So we have 1x, 9 positive units, and then 11 positive units. So we're going to go ahead, and I have some algebra tiles set up with my dot cam. I'm going to switch over to that, and we'll demonstrate how we would solve that. So here I have a x, and I have 9 positive units, and over here I have the 11. So this is our equal sign here, is this black line. Use that for an equal sign. Now I want to find out what just one x is. I want to isolate this variable. I want to get this x, or this bar here, this green bar that represents a positive x. I want to get it all by itself. So I need to get rid of these. I could just pull them off and remove 9 here and remove 9 there, and many students would do that with just like, well, I can take 9 away here, and I can take 9 away here, and I see that indeed 1x is equal to 2 positive units. However, so that we can be precise, make sure those there things stick to your fingers a little bit, and I'm going to go ahead and use the concept of 0 pairs so that we can understand that a little better, because that is quite important. So if I have the 9 positives on the left, I can add 9 negatives on the left as well. And so I'll slide all those over there. Got my 9 negatives I'm adding to the left side. And then if I add 9 negatives to the right side as well, slide all those up there. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can start removing 0 pairs. So I can get 2 of them. And there's 1 0 pair. Another 0 pair, 2 of them. 3, 4, 5, 6, 7, 8, 9. So I've created 9 0 pair, and I'm removing them from the left, leaving me with just the x. And then likewise, I'll do the same over here. Remember, a positive and a negative together equals 0. So positive 1 plus negative 1 equals 0. So I have 0 pairs here. And I'll go ahead and remove those. Almost there. Got a couple more to go. One more. And indeed, I then find out that x equals 2. So 1x equals 2 in this situation. So back here at my IXL screen, I'm going to have x equals, in this case, it's going to be 2, because we added 9 0 pairs to each side, remove those 0 pairs, and found that 1x equals 2. You could kind of look at this and think of it another way, as if I were to remove 1, 2, 3, 4, 5, 6, 7, 8, 9, if I remove 9 from there and 9 from there, I'd be left with 1x equals 2 units is what I would have left over. On the next one, we're going to use algebra tiles to solve 3x equals negative 24. So I'm going to set that up, and then we'll demonstrate that one. So here I've got that modeled. My 3 positive x's equals, in this case, 24, negative 1. So 3x equals negative 24. And on this one here, I want to find out what just the value of just one x, right? So I need to divide this into 3 separate groups equally. So I have 3 x's. I want to see what just one x is worth. So I've divided them into 3 to separate them out. Now divide my 24 units here, and this is kind of convenient because they are set up in 3 rows already, so I can kind of separate those out pretty easily. And sure enough, when you know it, lose my grasp on those. And now if I divide the left or the right by 3, just like I did the left, so I divided the 3 x's in 3 and got 1x, because 3 divided by 3 is 1. And then I divided the 24 negatives by 3, and whenever I divide a negative 24 by 3, I'm going to get a negative 8. So we can see that 1x indeed equals, and if you count them out there, there's 8 of them. So in this case, our answer on this one is x equals negative 8. One of these x's matches us up to just one row, and we have 8. So 1x equals negative 8. On our next one here, we have negative x minus 4 equals negative 7. I'll go ahead and set that up, and we'll discuss that because we're going to run into a problem here, because notice that we need our terms in a positive x right here. However, we have a negative x, and we'll see how that works. So let's take a look at that. So here's that problem set up with algebra tiles. I have a negative x minus 4 equals, looks like negative 7 was our problem. And so I need to first get this x by itself. Let's first try to isolate it, and we'll deal with it being negative. And I'm going to move that cursor out the way there. There we go. So we'll deal with that negative x after we've isolated it. We'll find out how do we turn it into a positive x. So in this case, I need to get rid of these 4 negatives. I could just remove 4 from this side and 4 from that side, but however, we want to go ahead and use the concept of 0 pairs. So I can add 1, 2, 3, 4 positives to the left, and if I add 4 positives to the left, I want to also add 1, 2, 3, 4 positives to the right as well. So I've added positive 4 to each side. I can now create my 0 pairs. Go ahead and create 1, 2, 3, 4 0 pairs. So I've created 4 0 pairs on the left, and then my 4 0 pairs on the right. 1, 2, and grab this here. I guess I'll be precise and put the negative at the bottom there. So I now have 4 0 pairs here. So all of this is 0, and all of this is 0 on each side. So we can remove those. So let's slide those out the way. We don't need those anymore. And then finally, I'm left with 1 negative x equals negative 3. However, my answer cannot be in terms of negative here. So if you remember the multiplication property of negative 1, that it changes negatives to positives and positives to negatives. Well, with algebra tiles, the equivalency of that is simply flipping it over. So I'm going to flip over the x here on the left and turn that to a positive, but if I flip the ones on the left, then I also have to flip the ones on the right, right? Properties of equality. What you do to one side, you do to the other. And I can now see that 1x equals positive 3. So let's go ahead and put that answer on our IXL activity. And that was 1x equals positive 3. So looking at our next problem here, we have x plus 5 equals 9. So I'm going to go ahead and set that one up. All right, so I've got that set up, and this is x plus 5 equals 9. So I could just remove 5 from each side, but I can't really do that if I want to do it properly. So I'm going to add 5 negatives to each side, 5 on the left, and 2, 4, 5 on the right. Now I can start creating my 0 pairs. Pull those off. 1, 2, 3, 4, 5 0 pairs on the left, And on the right, 1, 2, 3, 4, 5 zero pairs there on the right. So I see that 1x, in this case, equals positive 4. So let's go back to our IXL activity. And we decided and found out that 1x indeed equals a positive 4. So put in a positive 4 in there. Next one, let's look at this one here. Actually, I'm going to go up to another one here. This is the one that I want to use. So this will be my last one here. And the reason for it is, notice that we've been talking about being able to just remove from each side without using zero pairs. Well, notice here I have negatives on the left, but there's no negatives to pull on the right. So we'll look and see what that looks like. Let me get that set up, and we'll then continue. All right. Got that set up, so let's go ahead and start that discussion. So here I have 5 positive x, so 5x minus 6 equals 9. I've got that equation represented here with my algebra tiles. Now in the past we had stuff on both sides and we were making zero pairs, and the reason I was making those zero pairs is mainly for a problem just like this one here. Because, and once again there's my mouse in the way, let me move it, cursor out the way. So the problem is I can't simply just pull. I don't have red ones here to pull away, right? In the past we had maybe some positives here and positives here, and we could just pull from each side without using zero pairs. However, in this case we're going to have to use zero pairs, and that is because we don't have red ones to remove from the right side. So we're going to have to go ahead and add, looks like about 6. 1, 2, 3, let's see, 3, 4, 5, 6 positives on that side. So we're going to make our 6 zero pairs, and if I'm going to add 6 there, I also need to add 1, 2, 3, 4, 5, 6 over here as well. Now I can start create my zero pairs. Slide these over so I can start sliding those zero pairs out. And now I'm going to make 1, 2, 3, 4, 5, 6 zero pairs on the left. And now on the right, well, I don't have any zero pairs, right? I just added 6 to that side. So now I can slide my zeros out the way. And now I need to divide this into 6 equal groups, or 5 equal groups. I have 5 x's there. 1, 2, 3, 4, 5. And make sure you see them all on the camera there. Good job. And now I want to start dividing this group here into the 5 equal groups. So I'll just start out with like the 2 for me, 2 for you. Okay, we'll just give each of them 2 and see where we're at with that. And now we're down to, let's give each of them 1. And looks like sure enough that's going to turn out really nice to where we can see that each x is assigned to 3 positives. So in the end, I pretty much move all this out the way, and I see that 1x equals positive 3. So x equals positive 3. We'll go ahead and put that on our activity. So x equals a positive 3. And you'll see there are other problems like that one here with this next one here, right? We don't have positives to take away from the right. We could take them from the left, but not from the right. So in this case, we would have to, we'll go to the actual ones of this. So we'd have to add 1, 2, 3, 4 negatives on this side here. If we're going to add 4 negatives there, then we'd have to add 4 negatives here as well. And then these would equal 0 pairs. So I got 1, 2, 3, 4 0 pairs. So all of this is now canceled out. And I've got 4 x's remaining. And it looks like I have, 3 down the side here. And 1, 2, 3, 4, 5 there. So that's 15. And plus this one here, 16 plus 4 more is going to be a total of 20 altogether. So if I divide the 4 x's by 4 to see what just 1 x is, then if I divide, and that's a negative 20 actually, divide negative 20 by 4, I would get a negative 5. So in this case, we would see that just 1x, or that is to say that x equals negative 5 there. But we'd have to add some negative zeros here to create 0 pairs. So that's pretty much what they're want you to understand, is the idea of using 0 pairs. Also, it kind of takes the idea of algebra that looks something like this, and it's just numbers and variables and operation signs to whenever you use the tiles, you kind of actually see in the physical world what's going on there. So those are all of my examples for IXL A1.J.1. It was titled Model and Solve Equations Using Algebra Tiles. And good luck on your activity.